In 2025, almost all applications are using the GPU. AI, machine learning, games, movies, video editing, almost everything. But how are they using it? Are they using the device file located in the dev dry cards? Or what's happening here? And by the way, if you don't know what a device file is, you better then check one of my previous videos. It's only 5 minutes, this video, please have a look, and then we can continue from there. Now, with that said, Assalamu alaikum wa rahmatullahi wa barakatuh, ladies and gentlemen. Welcome to the application GPU communication on Linux. And as we always do, we go through an example and explain along the way. Imagine you already have a GPU inserted in your computer, and the kernel just went ahead and loaded the drivers. It created a file in the dev folder, and everything is ready for you to use it. Well, not you specifically, but the applications that wants to use it will be using it. For example, games. If they want to use it, they can use it. So what is the process? Imagine with me that you started an application that requires a GPU. First of all, your game will try to look for a graphics API on your system. Now that can be Vulkan, OpenGL, DirectX, probably you've heard of those. And if it finds it, it will use it. But what is a graphics API? Well, it just functions. Bunch of code that your application needs to use to communicate with the GPU. The fun thing is that these graphics API just forward the request to some other application, a library, bunch of code again, and that bunch of code is called Mesa. Yep, the real thing that talks to the kernel and asks about GPU stuff is called Mesa. So Vulkan, OpenGL, DirectX, whatever, they all are using Mesa under the hood. Basically, they're just wrapping Mesa. So what now? The application has successfully loaded the graphics API. It found Vulkan. It loaded Vulkan to the application. What's next? Well, now it's time to use the actual GPU. Let's say the game wants to do a simple operation to know the capabilities of the GPU inserted on your computer. So it will call some function, some code from the graphics API, which will call another piece of code from Mesa, which will finally do a system call to the kernel. Now this is important because this system call is to a specific part of the kernel called DRM, or Direct Rendering Manager. Now this part of the kernel consists of multiple codes, multiple modules, kernel modules, and its only sole purpose, sole responsibility is to make sure that the communication happen between your application and the graphics processing unit, the GPU. Now this DRM is part of the kernel, it's not a standalone driver. However, it uses the GPU drivers that the kernel loaded when you inserted the GPU into your computer. Finally, this DRM will talk to the driver, and that driver will obviously do some stuff on the hardware, basically talking to the GPU hardware. Now at this point in time, probably you will be asking yourself, then what about the dev dry device files? Do not they resemble the GPU, and shouldn't they be used? Because these are the devices files basically created by the kernel when you inserted the GPU into your computer. The fun thing is that they are used by the kernel, by the DRM module specifically. Mesa also uses that device files under the hood. For instance, if we take a quick look into the Mesa source code, we see that it opens the dev dry GPU file and give it to the DRM. And the first thing is that it loads the file by using the open file operation. So the file descriptor is gotten for that specific device file, and it uses the ioctl command. If we search, for example, for ioctl in the Mesa source code, you can see that it is all over the place. It's used everywhere. The idea of this ioctl is a function call responsible for calling the kernel. So it's a system call. So the kernel wants a system call for a device file using the ioctl function. The kernel will understand this ioctl operation and says, okay, I think I know what you're talking about, but I'm not the one responsible for doing it. This specific system inside of me is responsible for doing it. So it forwards the command to the DRM module, to the DRM subsystem. And the DRM subsystem understands what you're talking about. It takes the file descriptor, it takes the command that you've passed through the IOCTL, and it understands that specific operation. For example, you want to insert data, you want to load data into memory, you want to add this image into the GPU memory, etc. So it understands this part. Finally, the communication between the application and the GPU is designed this way instead of reading and writing to the dev device files directly, because the GPU is so damn complex. So complex. It has its own CPUs, memories, firmware, schedulers, etc. Everything. It has everything. It's almost becoming a computer itself. And again, in conclusion, the application is not really using the GPU device files located in the dev folder. However, it is being used to some extent in the DRM. Again, part of the kernel. And in short, our application is using Graphics API, which is a wrapper over Mesa, which is using the DRM, the Direct Rendering Manager inside the kernel, and the DRM is using the device file and the driver, GPU driver, and it tells the driver what to do. Finally, the driver tells GPU what to do. Thank you for watching. Feel free to like the video, or maybe dislike it if you don't like the spacing between the last word and the question mark. At this specific moment, I do not have ideas for the next video, so let me know down below if you have great ideas, and till that time, peace.